Hi everyone, this is Mr. Zhang, and today we'll be going over the math homework for Class P. This is for session U16. For question number 1, if 3x plus x plus x is equal to 10, then 5x times 5x is equal to. So here for the side, for the left side of this equation, we should really combine like terms. So when you combine like terms, you have to first identify the like terms in terms of the variables. So they're all in terms of x, which is good. And the last part is, of course, just adding or subtracting the coefficients. In this case, there is an invisible 1 for both of these x's, so just keep that in mind. When you do 3x plus 1x plus 1x, that's really just 5x. So the left side becomes 5x, which is equal to 10. And fortunately for us, 5x is what we need. You will replace both of these 5x's with the number 10. So then 5x times 5x just becomes 10 times 10, or 100. Choice E. You could also solve for x. If you do end up solving for x is equal to 2, and you can always just plug back in. Next, for number 2, in the correctly solved subtraction problem above, a and b represents digits. Now, what's the value of a times b? So here you know that 3 minus b is equal to 1. The only way that's in which that's possible is if you have 3 and 2. So you know that b has to be equal to 2. And then 8 minus a has to be equal to 3. You don't have to borrow anything. So when you do 8 minus a is equal to 3, you know that a has to be equal to 5. To the correctly solve the problem, I should say, is 83 minus 52, which is equal to 31. So now you don't want 52, you actually want a times b. And that's going to be 5 times 2, which is equal to 10. Choice D. For question number 3, points P, Q, R, S, and T lie on a line in that order. If PR is equal to 6 and PQ is equal to QR is equal to RS is equal to ST, then PT is equal to. So here, because you know that these 5 points lie on the same line and in that specific order, you can just start by drawing a line and just start labeling. So P, Q, R, S, T. Now it's not drawn to scale. Now PR is equal to 6. So that's from this piece of info. And then the next piece of info says that P to Q is equal to Q to R is equal to R to S is equal to S to T. So essentially P to T got split up into 4 equal pieces. Now, if you look at just P to R, we know that PR itself it's cut in half because P to Q is equal to Q to R. But P to R is 6, so that means that P to Q has to be equal to 3, and Q to R has to be equal to 3. So that means that each of these pieces has to be equal to 3. So if you add everything together to solve for PT, that's going to be equal to 3 times 4, or 12, and that's choice D. Next, for number 4, if the absolute value of x minus 6 is equal to x squared, then x could be equal to which of the following? So here you have this absolute value, and this absolute value means that if you have this absolute value, it could actually mean 2 things. If the stuff inside is positive or equal to 0, then the absolute value of x is just equal to x. But if the x inside this absolute value is negative, then the absolute value of x would be equal to negative of x, where you negate the negative number and then you get a positive number out of it. So depending on the situation, it could be either one of these. So to solve for this, you actually have to split up the absolute value of x minus 6 into 2 scenarios. One of them could be positive, one of them could be negative. So the positive case means that if x minus 6 is greater than 0. That means that the absolute value just goes away, so that's the easier case. You just have x minus 6 is equal to x squared. And the other case, if x minus 6 is negative, then that means that you have to negate this x minus 6 to be equal to x squared. So now from both of these equations, you can solve for them. So for the first equation, because it's actually a quadratic, you need to solve a quadratic equation by factoring. So you have to set equal to 0 and then factor. And once you factor, you can use a 0 property. So to set equal to 0, move everything to one side, specifically to the side with the x squared term. So that means you want to subtract x to both sides and then add 6. So your equation then becomes x squared minus x plus 6 is equal to 0. So that means that you have to factor now and then use a 0 property. You're looking for factors of 6. So 1, 6, 2, and 3. And you need to have a sum of negative 1. So you get that with 2 and 3, specifically a positive 2 and a negative 3. To have x plus 2 and then x minus 3. And when you solve for this, either one of these can be equal to 0. So x plus 2 could be equal to 0, or x minus 3 could be equal to 0. So in this case, x could be equal to negative 2, or x could be equal to positive 3. So we see both of these answers here, so let's substitute back in to check. So to check your work, you have to substitute back in. So if x is equal to negative 2, then the absolute value of negative 2 minus 6, you want to see if that's equal to negative 2 squared. So negative 2 minus 6 is equal to negative 8. So the absolute value of negative 8 turns into positive 8. And negative 2 squared is equal to 4. So 8, of course, is not equal to 4. So negative 2 doesn't work. Then you want to check to see if x is equal to 3. So if x is equal to 3, that would mean that positive 3 minus 6, if that's equal to 3 squared. So 3 minus 6 is equal to negative 3. I want to see if that's equal to 9. Well, the absolute value of negative 3 is just equal to positive 3, and 3 is not equal to 9, so C also doesn't work. So you know that this positive case can't be it. X minus 6 has to be negative. So the answer is actually here. So to solve for this, you can either divide both sides by negative 1, or you can take this negative 1 and distribute it to everything inside the parentheses. So that way is actually preferred. So let's use the distributive property. Negative 1 times x is negative x. Negative 1 times negative 6 is positive 6. And that's equal to x squared. So again, you have to solve this quadratic. This time you can add x and subtract 6 to both sides. And when you do that, you end up with the quadratic 0 is equal to x squared plus x minus 6. So again, you want the factors of 6. This time it's negative 6. And you want a sum of positive 1. And that works if you have positive 3 and negative 2. So this will be your two pairs. So that means that the factoring becomes x minus 2 times x plus 3 is equal to 0. So x could be equal to 2, or x equals negative 3. Now, I don't see positive 2 as a choice here, but I do see negative 3, so that's probably going to be your answer in choice A. You should always check your work. The absolute value of negative 3 minus 6, you want to see if that's equal to negative 3 squared. So negative 3 minus 6 is equal to negative 9, and the absolute value of negative 9 is positive 9, which is also negative 3 squared. So you know that this is correct. So here you can see that when you have an absolute value quadratic, it's pretty annoying to solve because you need to do a lot of steps. You always have to check your work because sometimes you have these extraneous roots over here and they don't work. So when you have a absolute value and a quadratic, and if you don't have any choices, you will just have to solve it using these multiple cases here, which is kind of tedious. If you do have choices, the easier way, especially if these numbers are really small, just substitute in. Once you plug it in, you can just double check, because you have to end up checking anyway. So that will probably save you a lot of time. If you have the open-ended responses, then you'll have to solve absolute value quadratics this way. But if you can avoid it, especially with multiple choice, you could just plug in and solve. Next, for number 5, Mr. Baroa teaches for 3.5 hours on each day that he is scheduled to teach. If he teaches D days per year, then which of the following is an expression of the total number of hours he teaches per year? So he teaches D days a year. Now he teaches 3.5 hours on each day. So the key word here is each. Each could mean multiply or divide. In this case, because we want the total, if we want the total and we see the word each, that means you want to multiply. You only divide when you already have the total. Here we want the number to get bigger, so you want the total, which means you want to multiply. So we'll take the D times 3.5 hours. So D days times 3.5 hours a day will be equal to 3.5D. And that's choice A. The other way to do this question is just to plug in random numbers. For example, he teaches 3.5 hours each day for 10 days, a year, whatever. Then you can substitute into all the choices with your really nice, easy numbers and use the process of elimination until you get to one choice. Next, for number 6, if j, k, l, m, and n are consecutive integers and j is less than k is less than l is less than m is less than n, then what is the value of j plus n minus k plus m? So here these are consecutive integers, and what consecutive means is that these numbers are right next to each other. And it has to follow a pattern. And integers are whole numbers. So these numbers are like 1, 2, 3, 4, 5, or 6, 7, 8, 9, 10. Where n is the biggest. So you want to figure out the value of j plus n minus k plus m. But when you have consecutive integers, you can just model them using small ones, like 1, 2, 3, 4, 5. They're really manageable. If you actually line them up such that you pair j plus n, the biggest and the smallest, and then the second biggest and the second smallest, you actually see that this is a shortcut of adding these numbers. 1 plus 5 is equal to 6, the biggest plus the smallest. The second biggest plus the second smallest is also equal to 6, and that's not a coincidence. When you pair up numbers in this way, especially if you have consecutive numbers, you'll have this nice pattern. So the difference between j plus n and k plus m will be choice A, 0, because these sums will be equal. J plus n will be equal to k plus m. So this is sort of that rainbow method of adding consecutive numbers. You always have this pattern if you have consecutive. Next, for number 7, when 1 is divided by 13 on a calculator, the repeating decimal is 0.076923. Repeating is produced. Which of the following is 7? So you have 300, 301st, 302nd, 303rd, or 304th digit to write the decimal. So, of course, you don't want to write this out to the 300th place value. That's too much work. You want to find a pattern. And the pattern here is this repeating decimal. So this repeating set of numbers has 1, 2, 3, 4, 5, 6 numbers. So the first is 0, then 7, then 6, then 9, then 2, then 3, and then repeats again. So that means that every 6th number is a 3, because 3 is the last number on the set. So that means that you can just take each of these and divide it by 6 to figure out that that would end the set. So you want a multiple of 6 that's into 300s. Well, 300 you can divide by 6 to go to 50. So the 300th digit will be a 3, because that is 300 is a multiple of 6. So then once you get to the 301st digit, it just keeps repeating. So the next one will be a 0. And the one following that will be the 7 that we desire. So it will be choice C. Again, here the key is to look for the pattern. The pattern repeats after every 6 numbers. So you divide by 6 to figure out the number of sets you have. You have 50 sets of 6. And you just want to keep going and repeating this pattern until you get to the number you want. Other times you'll want to get the remainder. The remainder will tell you how many times to go forward in the new set. Next, for number 8, which of the following expressions is equivalent to 2x squared minus 4x minus 16 divided by x squared minus 3x minus 4? So here you want to factor the numerator and the denominator. Now for the numerator, you see that 2, 4, and 16 all have a common factor of 2. Having this 2 in front of this x squared is actually really annoying. You have to factor by grouping. Unless, like what you have here, you can factor out. If you take a factor of 2 out, it makes it a lot easier because the numerator just becomes x squared minus 2x minus 8. And you're dividing by, you still have a 2 there. And you are dividing by x squared minus 3x minus 4. So when you start factoring, that factored expression is a lot easier because you don't have to factor by grouping. For the numerator, x squared minus 2x minus 8, you want factors of 8. That's 1, 8, 2, and 4. And you want factor of 8 that subtracts or adds to negative 2. And we see that with 2 and 4. Specifically, you want plus 2 minus 4. So it becomes x plus 2 and x minus 4. If you FOIL to check, that's just your first, outer, and last. You get x squared plus 2x minus 4x minus 8, or x squared minus 2x minus 8. So everything does check out. So the numerator is 2 times x plus 2 in parentheses and x minus 4 in parentheses. Then you have to do the same thing for the denominator. So the denominator is x squared minus 3x minus 4. In this case, you want factors of 4. So that's 1, 4, 2, and 2. And you want a sum of negative 3. You get that with 1 and 4. Specifically, it's plus 1 minus 4. So this would be x plus 1 times x minus 4. Now we should always check. You could check by FOILing. That would be x squared minus 4x plus 1x minus 4. And when you combine the middle two terms, you get x squared minus 3x minus 4, which is exactly what you have here. So everything does check out. Then when you put this in the denominator, you see that x minus 4 actually cancels out with the x minus 4 in the numerator. So because that's gone, you have this left. And from here, you can just redistribute the numerator to give you choice D, 2x plus 4 divided by x plus 1. So for number 8, you have to factor a couple times, and then you cross out any common factors. All right, and here is the summary for this first page. All right, next for number 9, the circle with center P, shown above, has a circumference of 10 pi. If xy is equal to 6, what is the area of the shaded region? So here we know that the circumference is equal to 6. So circumference is kind of like the perimeter. So circumference is formula is 2 pi r, and we know that's equal to 10 pi. So from here, if you divide both sides by 2 pi, you get that the radius is equal to 5, or 10 over 2. So you know that radius is equal to 5. And to get this shaded area, kind of in a weird place, you actually have to do the area of the semicircle subtracted by the area of the triangle. And that will give you the shaded area. So to figure out the area of the semicircle, that's just pi r squared times 1/2, because the area of a circle is pi r squared. And the semicircle just half of the circle. So when you substitute in the radius of 5, you get 1/2 pi times 5 squared, or 25 pi in the numerator divided by 2. So that's the area of the semicircle. And now you're going to be subtracting something. So you'll be subtracting the area of the triangle, which is triangle XYZ. So to get the area of this triangle, we know that x to y is equal to 6. That's given here. X to z is 5 and 5, which is equal to 10. So this is actually one of these special triangles. It's a Pythagorean triplet. Because you have this right angle here, this is a special right triangle. It's you can always just use Pythagorean theorem to figure this out if you forgot this triplet. And Pythagorean theorem states that a squared plus b squared is equal to c squared if you have the two legs, a and b, and a hypotenuse of c. Now this triplet that we can use for this Pythagorean triplet is actually a multiple of a 3, 4, 5. A triplet is just a set of 3 whole numbers that satisfies Pythagorean theorem. In this case, it's a multiple of the 3, 4, 5, which is a 6, 8, 10. You take a 3, 4, 5, you double all the sides, you get a 6, 8, 10. So once you know that the base is 6 and the height is 8, and these are perpendicular, you can use the area of the triangle, which is 1/2 base times height, which is 6 times 8. So you'll be subtracting 1/2 of 6, or just 3, times 4, which is 24. So the answer is 25 pi divided by 2 minus 24, choice E. So here the key was to use the circumference formula to get the radius. You definitely need the area of a circle as well. And then you have a Pythagorean theorem, which is a squared plus b squared equals c squared. And the shortcut we used was the Pythagorean triplet. The other triplets that you have to know is 5, 12, 13. We use the 6, 8, 10, which is just a multiple of the 3, 4, 5, but you also need a 5, 12, 13 as well. Next, for number 10, if a is equal to 2 raised to the 2m plus 2, and b is equal to 4, then a divided by b is equal to. So here, you have to divide these two quantities. So the numerator is 2 raised to the 2m plus 4, 2m plus 2. And the denominator is equal to 4. Now, it looks like we can't really do anything, but we actually have to turn these bases the same. So we know that 4 can be rewritten as 2 squared. So once we put in 2 squared into the denominator, you get 2 raised to the 2m plus 2 divided by 2 squared. And now that the bases are the same, we can actually use one of the laws of exponents. B to the a divided by b to the c is b to the a minus c. So this is the law of exponent, where if you divide two exponents of the same base, you have to subtract the exponents. So you have to subtract these exponents here. This would be 2 raised to the 2m plus 2 minus the denominator, which is 2. And when you subtract 2, of course, that cancels out with the positive 2. So you're just left with 2 raised to the 2m, which is choice B. All right, next for number 11. So this is the start of the fill-in section, or open-ended, I should say, where you have to just bubble in the numbers. So if 5 times 10 to the 5th power minus parentheses 4 times 10 to the 4th power is equal to b times 10 to the 5th power, then what is the value of b? All right, so for this question, you have a couple things written in multiples of, multiply by powers of 10. So here you can just write out the number. When you multiply by a power of 10, you just move the decimal point. So this 5 becomes, or 5 zeros, or 500,000. And subtracting this 4 followed by 4 zeros, or 40,000. So that's 500,000 minus 40,000 when you line up the place values. And you get 460,000. Or sorry, 460,000. So 460,000 written with this scientific notation where you have times 10 to the 5th means you have to divide both sides by 10,000. Or sorry, 100,000. And that'll cancel out with 10 to the 5th. So if you divide by 100,000, the 3's cancels out, the zeros cancel out, and you have 46 divided by 10, which is just equal to 4.6. So B is 4.6. Next, for number 12, a rectangle has a perimeter of 10. If the lengths of the sides are all integer values, what's one possible value for the area of the perimeter? So they're all integers, which means it's a whole number. So remember, a rectangle has 4 sides, so you can just make one of them 1. If we make 2 sides of this rectangle 1, the other side has to be 4 and 4 to make the perimeter of 10, which means that the area will be 4 times 1, or 4. Now you can also increase it to get an area of 2, or sorry, a side of 2, which means that you have 6 more left to distribute. This would be a 2 by 3. So the perimeter is still equal to 10, but the area is now 2 times 3. It's a little bigger at 6. And that's it. If you try to increase it to 3 and 3, you just get this the same shape, but just rotated. And then if you increase it to 4, you got 4, 4, 1, 1, which is the same as this shape. So there are 2 answers. The area could be equal to 4, or the area could be equal to 6. Now you just need to bubble in one of them. You don't need both. Next, for number 13, you have this bar graph. Now, Miranda picked apples with her friends. If she picked 15 apples, according to the information in the graph above, what is the total number of apples picked? So here Miranda represents 30%. So 30% is actually equal to 15 apples. Then we can figure out the total, which is just another way of saying 100%. So if you divide both sides by 3, we can get sort of the unit base rate. 30 divided by 3 is 10%, and 15 divided by 3 is 5 apples. So if 30% is 15 apples, 10% is equal to 5 apples. And then you can multiply by 10 on both sides to get to 100%. So that means that 100% will be 5 times 10, or 50 apples. So the answer is 50. Next, for number 14, if g to the n is a geometric sequence whose nth term can be expressed as 8 times 6 to the n minus 1, what's the value of g to the 6 divided by g to the 8? So here we have to know how to read this geometric sequence. A geometric sequence is a sequence, and a sequence is just a list of numbers. So some pattern. It's a list of numbers where the pattern is you keep multiplying to get to the next term number. So in this situation, we can actually come up with the general form for geometric sequence. So g of n is equal to a times r raised to the n minus 1 power. So a is the first term, r is the common ratio, or just a number you multiply by, and n is a term number. So if you come up with the table of values, for example, you have the term number and then what the value is. The first number is a, so term number 1 is a. The second term will be a times r. The third term will be a times r times r. The fourth term will be a times r times r times r. So that's a pattern, just keep multiplying by r's. And here you see that to get to the fourth number, you have to multiply by r 3 times because you start out with the first term already. So the general format is just the first term is a, then you have a times r to the first power, then a times r to the second power, a times r to the third power. So the exponent is always 1 less than the term number here. So when you have g to the 6th divided by g to the 8th, the 6th term to the 8th term, if you look at this expression, the 6 is actually the common ratio. The first term is 8. So if the pattern is multiplied by 6, well, to get to, if you have the 6th number, then you get to the 7th number, and then you get to the 8th number, you actually have to multiply by 6 2 times. So this fraction has a denominator that is 6 times 6, or 36 times bigger than the numerator. So this fraction will be g to the 6 times 36 times g to the 6, because the 8th term is the 6th term times 6, or times 36. So g to the 6 will cancel out, and the final answer will be 1 over 36. So that's the answer for number 14. It's 1 over 36 if you read this geometric sequence, this expression. So this is something that you'll want to memorize. The nth term of a geometric sequence is a times r raised to the n minus 1. And a is the first term, r is the common ratio, and n is the term number. Next for number 15, if a is a set of all positive integers less than 300, which are divisible by 3, and b is a set of all the prime numbers, the intersection of set A and set B has how many elements? So a set is just a list of numbers as well. But there's no pattern here. It's just denoted by these curly brackets. And the numbers inside are called elements in this set. Now A has all the positive integers less than 300. So set A would be equal to all the numbers that are less than 300 that are divisible by 3. So just 3, 6, 9, 12, etc., all the way up to 300. It's the 3 times table, up to 300. And since 3 times 100 is equal to 300, you know that there are 100 numbers in this set, or 100 elements. Now for set B, it's a little different. Set B has all the prime numbers, and you have an infinite number of prime numbers. So this set will go to infinity, but prime numbers have exactly 2 factors. So the 2 factors are just 1 and itself. So you start out with the number 2. 2 is the smallest prime number, is also the only even prime number. Then you have 3, then 5, 7. You skip 9 because 9's not prime. You go to 11, then 13, 17, etc. And it goes on forever, doesn't end. Now, what you need to find is actually the intersection. And the intersection is a very specific meaning. So the intersection of A and B is also symbolized by this upside down U. So A intersect with B means common elements only. So the overlap. And fortunately, even though set B has an infinite number of numbers, because they're all prime, there's only one number that intersects. The intersect of A and B is just equal to set with 3 in it. 3 is the only prime multiple of 3. All the other numbers that are multiples of 3 are not prime. They're composite. They'll have a multiple. They'll have a factor of 3, so they have more than 2 factors. So because of that, the intersection of A and B will have just one element. So the answer is 1. And that one number is 3. Now, another word that you also need to know when you talk about set notation is whereas intersection equals common numbers only, the union represents all the numbers together. It's kind of like united. They're all together, but no duplicates. So you don't double count. You only count once. So duplicates only count once. So that's the other thing that you might see. The symbol for intersection is this upside down U. A union is a actual U. So don't get those two mixed up. All right, and here is the summary for this page. Next for number 16. If three fifths of 1/3 is divided into 4, what is the resulting value? So here for this problem, you just have to turn the word sentence into a number sentence. So of means multiply, and divided means divide, but you're dividing into 4. So that means that you got to switch the order. So for example, if you have 2 divided into 4, that means 4 divided by 2, not 2 divided by 4. So just be wary of that. So you have 3/5 times 1/3 as a multiply. They have to do first. In this case, the 3 gets canceled out, so you just have 1/5. So the 3 in the numerator gets canceled out with a factor of 3 in the denominator. And I have this 1/5, you're dividing it into 4. So that means 4 divided by 1/5. And when you do 4 divided by 1/5, you gotta do keep, change, flip. So that's gonna be 4 times 5/1. When you keep, change, flip, the 1/5 becomes the reciprocal, which is 5/1. And here, this is just 4 times 5, or 20. So again, here it's a little tricky with the dividing into. So just be wary of that, because when you divide, order matters when you divide. So just be wary of, 2 or 4 divided by 2 is just 4 divided by 2. But so if you have 4 divided by 2, that's 4 divided by 2. But if you have 2 divided into 4, that's 4 divided by 2. So these are the same meaning when you switch the order. Next, for number 17, Ronaldo's building a model car. He can choose up to 3 of the following accessories to enhance it: glow-in-the-dark hubcaps, movable windshield wipers, and smiling passengers. If he chooses at least one, how many distinct combinations of accessories are possible? Now you gotta note the order is not important. So that means the order doesn't matter, which gives you more possibilities. Or it gives you fewer possibilities. Now, the key here is that he can choose up to 3. So if he chooses 1, You can pick either the hubcaps, H, you can pick the windshields, or you can pick the smiling passengers. So you have 3 choices. Now if you choose 2, then you have to choose a pair. You can have H with W or H with S. Or you can choose W with S. So again, that's also 3 possibilities. Again, here order does not matter. So HW, if you pick the hubcaps and then the windshield, that's exactly the same as choosing a windshield first and then the hubcaps. So order doesn't matter here. If order did matter, we would have 6 options: HW and WH, HS and SH, and then WS and SW. But here, because order doesn't matter, you still have the same 2 accessories. You only have 3 possibilities. And then finally, if you choose 3, well, there's only one option, HWS. So if you add everything together, you have 3 plus 3 plus 1. Or there are 7 total unique combinations in which order does not matter. And what we have here, if order doesn't matter, this is called a combination as opposed to a permutation. So when you have a combination, the order doesn't matter. AB is equal to BA. When you have this option, this is essentially picking group members, for example, picking your team. It doesn't matter if you choose person A first, then person B, then person C. It's the same group of 4 people. If you choose C, then B, then A. Next, for number 18. Each face of a box to be covered with a piece of decorated paper. If the box has its dimensions shown in the figure above and no paper is wasted, what's the total area of the paper needed to complete the job? So to cover up this surface, this is called surface area. And the formula for the surface area of a rectangular prism is 2LW plus 2LH plus 2HW. So length is equal to 11, height is equal to 4, and width is equal to 6. All I have to do is substitute in. So that's 2 times 11 times 6 plus 2 times 11 times 4 plus 2 times 4 times 6. So this would be 22, or 2 times 66, which is 132, plus 2 times 44, or 88, plus 2 times 24, which is 48. So when you add 132, 88, and 48 together, you get 268 as the surface area. So again, here the formula is what you can use here. Remember, this formula actually comes from when you open up this net diagram, it turns into the shape, and then you just add each of these areas. Next, for number 19, Chucky the Clown makes balloon animals for birthday parties. He charges his customers according to the following rates. One's a general fixed fee for attending the party, so that's a flat fee, and is an additional fee for each 1/5 of an hour that he works. The final bill for 2 3/5 hours of work is $24.50, and the final bill for 4.5 hours of work is $38.75. What's the final bill in dollars for 1 hour of work? So here, this is actually your system of equations question. Because you have 2 variables, the fixed fee, which we'll call F, and then the additional fee for 1/5 of an hour, we'll call R, his regular rate. So for the first equation here, in terms of F and R, it's 24.50 that's his the money he gets, is equal to his flat fee, which is F, plus, since he worked 2 3/5 hours, and he gets his hourly rate of 1/5 of an hour, he gets his rate, we can actually figure out how many 1/5s are there. Or if you look at the unit, we actually don't really care about the 1/5. We just want to know his rate for 1 hour of work. So instead of calling his rate every 1/5 of an hour, cross it out, we can use his rate R to be equal to 1 hour of work, which is what we're looking for anyway. So if he gets R dollars every hour of work for 2 3/5 hours, that's 2.6 R. And then for the second equation, you get $38.75. That's equal to the same flat fee, but now you're adding 4.5 hours of work, so that's just 4.5 R. Again, we're using R to be equal to 1 hour of work, which is what we're looking for. So when you have the system of equations, you can either solve by doing substitution or elimination. In this case, we're going to be using the elimination method because if you look at the system of equations, none of the variables are isolated. If none of the variables are isolated, we use elimination because that will actually help us save some time. Here we make the coefficients the same, and here the variable f, this flat fee, is already the same, has the same coefficient. So all we have to do is subtract these two equations. The flat fee f, one of our variables, cancels out. And what you have left is $14.25 is equal to 1.9 R. So then you'll have to divide both sides by 1.9. And you get that his rate is equal to $14.25 divided by 1.9. Or if you just move the decimal point over, it's 142.5 divided by 19. So here you can estimate 19 is about 20. So 19 times 7 is going to be what you start with. And that's equal to 133. So 7 times 19 is 133. You subtract, you get 95. And then 19 goes into 95 exactly 5 times. And 5 times 19 is 95, which is 0. So there's a decimal point here, so make sure you float that up. That means that for each hour, you'll get $7.50 for each hour. Now, once you have this hourly rate of $7.50, remember this is the variable R, you want to figure out the final bill. And this final bill includes this fixed fee. So once you've solved one of the variables for a system of equations, you have to then substitute back in to solve for the other variable. So in this case, you could use either of the two equations that we started with here and substitute back in $7.50. So the first equation is actually a bit easier because the numbers are a bit smaller. So for the first equation, specifically this one here, you'll take 750 and substitute in. So that means that for 2 3/5 hours of work, or 2.6 hours, each hour is going to cost you $7.50. So you're going to multiply this by 7.5. And that will be 182. And then I have to move the decimal point 2 places. So it'll be 1950. But then you have to add this flat fee. So 1950 plus F is equal to $24.50. So to figure out the flat fee, you're going to have to subtract 1950 on both sides. and 14 minus 9 is equal to 5. So the flat fee is going to be equal to $5. Now, once you figure out that F is $5, the rate is $7.50 for 1 hour of work, you'll have to add these two answers or these two numbers together. Because for 1 hour of work, you pay the flat fee, which is $5, and then the hourly rate is going to be $7.50. So you add 5 plus 7.50, and the total will be equal to $12.50. And that is the final answer. So for the system of equations, we use the elimination method to solve for one of the variables, R, the hourly rate. When you solve for the hourly rate, you can substitute back in to the other equation to solve for the flat fee. And then you can put both of them together to figure out the final bill. Next, for number 20, Adam, Justin, Doug, Dan, Ed, and Meredith go bowling. If Meredith's score is 6 times the average, the arithmetic mean score for the other 5 players, then her score is what portion of the total score for all 6? So we don't know what their scores are, but we know that Meredith's score is 6 times the average. So M for Meredith is 6 times the average for the others. And the key here is, of course, average. Average means the total sum divided by the number of data. So in this case, the average for the others would be the total for 5 of them divided by 5. And 6 times that will be equal to Meredith's score. So to figure out the portion or the part of the total score for all of these 6 players, specifically that's Meredith, you want Meredith's score divided by the total. And this is the fraction. Her score is, of course, a part. The whole is a total. So then we can replace everything. Again, Meredith's score in terms of the total is this. So this will be the numerator. It will be 6 times the total divided by 5. And you're dividing this whole thing by the total T. That's for the 5 people. Plus Meredith's score, which will be 6 times T to the total of 5 people divided by 5. So you can just replace the total with just one variable, T, and this variable, you can just carry it through. Anyway, so when you have this, you'll want to simplify the denominator first. And when you simplify the denominator, the LCD is equal to 5. So instead of T to 5, that's a little confusing. So I'm just going to replace this with the variable T. So again, for the numerator, it's Meredith's score, which is 6 times the total of 5 players. We'll just call that T. So 6T divided by 5. Now the total for everyone is 6T over 5. This is Meredith's score. Plus T, which is the total for the 5 others. Remember, there are 6 people playing or 6 people bowling. So from here, you want to simplify the denominator. And for the denominator, the LCD is 5. So it's really 6T over 5 plus 5T over 5. And when you add them together, you get 11T over 5. And for the numerator, it's still 6T over 5. So from here, you can rewrite this complex fraction which is just a fraction inside a fraction using the fact that this main fraction bar means divide. So you turn this into 6t over 5 divided by 11t over 5. And when you divide fractions, you gotta keep change flip, or KCF. So once you keep change flip, you get 6t over 5, which you keep. You change the divide into multiply, and then you do the reciprocal, or you flip the second fraction into 5 over 11t. And from here, you can actually see that the 5 cancels out with 5 in the numerator. The variable t, the total of the 5 people, that's just a constant, that also cancels out. And you end up with 6 over 11. And that's a final. Okay, and here's the summary for this page. Next, we're question number 1. In the correctly worked subtraction problem above, if m and n represents 2 distinct digits, or just 2 different numbers, then what's the value of n? So for this one, you have to start with the ones place. So you know that 9 minus m is equal to n. And this m minus 3 is equal to 4 in the tens place. And because that 1 in the hundreds place doesn't change, so you don't have to borrow or anything, that means that m minus 3 has to be equal to 4. And that means that m has to be equal to 7. So once you figure out that m is equal to 7, you can then substitute back in. It will be 9 minus 7, which has to be equal to 2. So n has to be equal to 2, which is choice B. So this problem will be 179 minus 32. And the answer is 147. Next, for number 2, in the figure above, line A, B, and CD are parallel, and they are intersected by EF. What's the value of W plus Y plus Z? So when you have parallel lines, that means that they never meet. And because they never meet, and they never intersect, you can actually mark them up this way. And you also have what are called corresponding angles. So corresponding angles form when you have a pair of parallel lines and to the line that cuts through, and specifically it's angle Y and angle W. And these corresponding angles, they are congruent. So they form this letter F. So here, you know that angle W and angle Y are equal. Now, what you also have when you have any of the lines set up is that if you have an X, specifically those two lines, if you have DG and line EF, when you have this X, you have these two angles are also equal. And these are called opposite or vertical angles. And opposite or vertical angles are also equal. So you know that Y is equal to 100 degrees. And since Y is equal to W, because they're corresponding, W is also equal to 100 degrees. And then Z would give you the remaining 80 degrees, because you know that Y and Z, they make a straight line, and that straight line is supplementary. Which means they add up to 180 degrees. To find Z, you have to do 180 minus 100, which will give you 80. So for this question, you have the classic setup. You have corresponding angles, opposite or vertical angles, and also supplementary angles here. And they are all a part of this problem. You do those combination of these three to figure out that W plus Y plus Z will be equal to 100 plus 100 plus 80. Or choice D, 280 degrees. Next one, number 3, if x is equal to y plus 2 and y is equal to 4, then 3 over 2x is equal to, so here you know y is equal to 4, so you can substitute in to the first equation. So instead of x equals y plus 2, you replace y with 4, so then x will be equal to 4 plus 2, which is equal to 6. So once you know that x is equal to 6, you can take the 6 substitute in to that 3 halves of x. So that would mean that 3 halves times 6, that's going to be equal to, when you cross simplify, 3 times 3. You can also put 6 over the denominator of 1. So 3 times 3 will be equal to 9, and that's choice B. Next, for number 4, in the figure above, ABCD is a rectangle. If W is equal to 100, then Y plus Z is equal to. So here, you know that a rectangle, all the angles are right angles. So in a rectangle, all the angles are equal, and they're equal to 90 degrees. So you know that Z has to be 90 degrees. Now, you're also given the fact that W is equal to 100. So you can replace this angle here with 100 degrees. And this part is the supplement of W. So it's that same angle that we see up here. Supplementary angles, they add up to 180 degrees. So we have a straight line here. This angle is equal to 180 degrees, and this angle is made up of 2 angles, W plus this missing angle, which we don't know what it is, so we can call it A. W plus A has to be 180 degrees. Now, W is equal to 100, so that means that A would be equal to 180 minus 100, or 80 degrees. So if A is equal to 80 degrees, that means that Y would be 90 degrees minus 80 degrees, which is equal to 10. Get Y is equal to 10, and Z is equal to 100. Or, sorry, Z is equal to 90. Because it's a right angle. Double is equal to 100. You add them up, and you get 100 for Z plus Y. That's choice B. Next, for number 5, the total distance that a car can travel varies directly with the amount of gas in the tank. A certain car can travel 270 miles when its tank is 3/4 full. If a car's tank has 12 gallons in it when it's 3/4 full, how far in miles can a car travel on a full tank of gas? So here you know that you can go 270 miles if it's 3/4 full, and 3/4 full represents 12 gallons of gas. So these are all the quantities that relate to one another. Stuff that I have in orange. Now, here you actually want the full tank. And because everything varies directly, what that means is it's proportional. So if it's proportional, what you can do is use the unit rate. You can also solve this using proportions or unit rates. So the unit rate might be a little easier because we have 3/4, so you can multiply 3/4, or rather you could divide it by 3 to figure out the unit rate. In this case, 3/4 divided by 3 will be just 1/4. When the car's gas tank is 1/4 full, that would be 12 divided by 3, or 4 gallons of gas. And that would mean that 270 divided by 3 would be 90 miles. It can only travel 90 miles. So you divide everything by 3. But we don't want the gas tank when it's a quarter full. You want a full tank, which is 4 out of 4. So then you multiply by 4 on all 3 sides. Again, you do this because it's proportional. It's directly related. So if you multiply by 4, this would be 4 out of 4 full, or just full tank. That means it's going to be 4 times 4 gallons, or 16 gallons. That's the capacity of the tank. And that also corresponds to 90 times 4, which is 360 miles. So this will be the full range of the car. Of the full tank, it can travel 360 miles, which is choice D. Next for number 6, if 10 plus the square root of x is equal to 154, then 10 times the square root of x is equal to. So here, the first thing you can do is subtract 10 on both sides. And you get that the square root of x is equal to 150 minus 10, or 144. So here, you could actually solve for x by squaring both sides, but you don't have to. You don't want to solve for x. You want to solve for this expression, and this expression, fortunately for us, includes the square root. So you can just replace this 144 into this entire square root of x expression, which means this will be 10 times, instead of square root of x, this is 144. And 10 times 144 is 1440, which is choice E. Next for number 7, if the point 1, 3 is on the graph of f of x, which of the following points must be on the graph of f of x plus 2? So this is a transformation of functions. And when you have a transformation of functions, if the x plus 2 is inside the parentheses, that means you actually shift the graph left. So it's kind of towards the opposite. And when you shift it left 2 units, you subtract 2 for the x. So instead of 1, 3, it'll turn to negative 1, 3, which is choice B. So this is something that you have to memorize. F of x minus 2, this would shift up 2 units, or sorry, not up, shift to the right 2 units, which is the opposite. If you have, on the other hand, f of x plus 2 on the outside, this will be up 2, whereas f of x minus 2 will be down 2. So depending on where the change is, if it's inside or outside the parentheses, the graph will either shift up, down, left, or right. Next for question number 8, 90% is 50% of 90% of what number? So here you have to turn the word sentence to a number sentence. So 90 is means equals to. So you have 90 is equal to. The next part, 50% means 50 percentile, or 50 over 100, which is just equal to 1/2. Now this of means multiply. And this 90% represents 90 over 100, which is equal to 9/10. And the next of means multiply again. And finally, what number represents your variable? So we can call that x, or in this case, we'll just call it n. So here's your equation. 90 is equal to 1/2 times 9/10 times n. And we just have to solve for n. So to solve for n, you'll have to multiply both sides by the reciprocal of the fractions to get rid of the fraction. So a reciprocal is an upside down fraction. Instead of 1/2, you can multiply by 2 over 1. And when you multiply by 2 over 1, the 2 in the numerator cancels out with 2 in the denominator. So you're just left with 1. And then you also want to multiply by 10 over 9, because the 10 in the numerator cancels out with 10 in the denominator. 9 in the denominator cancels out with 9 in the numerator. And again, whatever you do to one side, you got to do to the other side. So n, which is left over on the right side, is equal to 10 over 9 times 2 over 1 times 90. Now, from here, 90 in the numerator, this is really 90 over 1. Cancels out with the 9 in the denominator. You have 10 left in the numerator. So the numerator is 10 times 2 times 10, or 200. And that's choice B. So for number 8, you have to turn the word sentence to a number sentence and just multiply by the reciprocal to cancel out the factors. And you want to isolate the variable n. Next for number 9, how many 2-digit numbers have a tens digit that's an even number and a units digit that's an odd number? So this is a counting principle question, or just a tree diagram question. Here, when you're making a 2-digit number, you have the tens place and the ones place. So you want to know 2-digit numbers, they have a tens digit that is even. So in the tens digit, you can only put 2, 4, 6, 8. So you have 4 options here. You can't put 0 in there because that wouldn't be 2 digits, that'd just be 1 digit. So you have 4 branches. And for the ones place, you want something that's an odd number. So for odd numbers, you have 1, 3, 5, 7, and 9. That's 5 options here. So you always want to multiply when doing accounting principle. 4 times 5 is equal to 20. That's choice C. You want to track the number of choices. For the tree diagram, you have 21, 23, 25, 27, 29. So 5 numbers in the 20s. Then you have 5 numbers in the 40s. So 41, 43, 45, 47, and 49. And then for the 60s, you have the same 5, 61, 63, 65, 67, 69. And last but not least, for the 80s, you have 81, 83, 85, 87, and 89. So all in all, you have 20 branches. And here's a summary for this page. Next up for number 10, I have this figure not drawn on a scale. In the figure above, ABE is a triangle and EBCD is a rectangle. AE is equal to 9 and AB is equal to 15. And the perimeter of EBCD is 40. You want to figure out the area of EBCD, this rectangle. So the first thing you have to do is, you know that rectangles have right angles. And because you have a line AD here, you know that angle AEB is also a right angle. So this triangle, ABE, this is actually a right triangle. And for right triangles, you can use Pythagorean theorem. Which states that for all right triangles, the relationship between the sides is a squared plus b squared is equal to c squared. So you can set this up with 9 and 15, but this is actually one of your Pythagorean triplets, so we can take a shortcut. This is actually a 3, 4, 5 multiple. If you take a 3, 4, 5 and you multiply everything by 3, you get 9, 12, 15. So the 3 sides will be 9, 12, and 15. You have the 9, you have the 15, the last piece has to be 12. And for rectangles, opposite sides are equal. So BE is equal to CD, they're both equal to 12. Now once you know that the heights are equal to 12, you can solve the bases, which you can just call B for base. You know that 12 plus 12 plus B has to be equal to 40. So 40 is equal to 12 plus 12 plus B plus B. Once you combine like terms, 12 and 12 is 24. And B plus B is equal to 2B. So to solve this equation, you subtract 24 on both sides. You get that 16 is equal to 2B. Then you have to divide by 2 to get rid of the coefficient. And that'll give you B is equal to 16 over 2, or 8. Once you know that the base is equal to 8, you can solve for the area, which is just 12 times 8. Because area is base times height, which is 12 times 8, or 96. And that's choice C. Now for this question, you have to use Pythagorean theorem. And we can use a shortcut, the triplet, specifically the 3, 4, 5 triplet, and a multiple, if you multiply everything by 3. Next, for number 11, Stefan takes 240 minutes to draw 20 pictures. How many pictures will he draw in 6 hours if he draws 3 times faster than the given rate? So right now his current rate, or speed, for drawing pictures is 240 minutes for 20 pictures. Now if he draws 3 times faster, that means that in the same 240 minutes, in that same time frame, you can draw 3 times as many pictures, so that's 60 pictures. And you want to figure out how many pictures you can draw in 6 hours. Well, in 240 minutes, you can divide by 60 to figure out that 240 minutes It's 1 hour, 60 minutes. If you multiply it by 4, in 4 hours, that will be 240 minutes. So this is 4 hours for 60 pictures. And you can find the unit rate, which you can divide by 4. So that each hour, that is a triple rate, that would be 15 pictures. And you want to figure out how many you can draw in 6 hours. So if you multiply by 6, 6 hours will give you a rate of 15 times 6, or 90 pictures. And that's choice D. Next, for number 12, x plus 6 is a factor of all the following rational algebraic expressions, except. So here you have to go through all the choices and you have to factor everything. But you can always use process of elimination to make things a bit easier. So for choice A, you can use the factoring pattern. X plus A squared is equal to x, or just x plus y. X plus y in parentheses squared is equal to x squared plus 2xy plus y squared. So we actually have that set up. Here, if we factor the numerator, factor the 36, you'll use a factor 6 and 6. So you have x plus 6 times x plus 6 divided by x plus 6. So one of them will cancel out, so the answer will be x plus 6. So of course that is a factor, so you can eliminate choice A. Similarly for choice E, this is the difference of two squares. X squared minus y squared is equal to x plus y times x minus y. So this would be x plus 6 times x minus 6 when you factor it. In the denominator, if you factor out x, you have 6 times x minus 1. And here, because you have x plus 6 in the numerator, that counts as a factor, because factors have to be in the numerator. You can rewrite this as x plus 6 times the remaining factors. So this original expression is equal to x plus 6 times this other really large factor. So I have to do that to each of the choices and just make sure that x plus 6 can be in the numerator. So for choice B, you can actually see that specifically this term has a 3 in front of it, which means that you have to do factor by grouping. You have to do that for the other choices too, so it's definitely a little tougher. And to do factor by grouping, you have to multiply the first term times the last term in the numerator. So here, you want to look for factors of 3 times 12, or 36. So that's 1, 36, 2, 18, 3, 12, 4, 9, and 6, 6. And you want to add them up with 16. So you see that 16 is the factor if you have 2 and 18, specifically positive 18 and negative 2. So this numerator will turn into 3x squared plus 18x minus 2x, and 18x minus 2x is equal to 16x minus 12. And the denominator, you can just factor out x squared. So for the numerator here, you would then factor by grouping. For the first term, you can factor out 3x. For the second half, you can factor out a negative 2. So that would lead to 3x times x plus 6. And then negative 2 times x plus 6 as well. So that's where that x plus 6 comes from. And from here, you can factor out the x plus 6 from both of these terms. So that would lead to x plus 6 times the remaining 3x minus 2. And You can always FOIL this to double check. Divided by x squared and 3x minus 2. So 3x minus 2 actually cancels out. Choice B simplifies to x plus 6 divided by x squared. And because you see x plus 6 in the numerator, that is a factor. Now for choice C, if you multiply 3 times 3, that would be 9. So factors of 9 would be 1, 9, 3, and 3. And there's really no way to get negative 5, so that's a big hint that this is probably not going to be it. You can't have any rational factors here. So in order to solve for choice, now because you don't have any rational factors, because 1 and 9 can combine to form negative 5, and there's no way 3 and 3 can combine to form negative 5, you're going to have to use the quadratic formula, which really is a last resort. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac divided by 2a, where a is the coefficient of the first term, in this case it's 3. B is the coefficient of the second term, which in this case is negative 5. And C is the coefficient of the last term, which is positive 3. So when you substitute in, this would be negative of negative 5 plus or minus the square root of negative 5 squared minus 4 times 3 times 3, all divided by 2 times 3. So this is 5 plus or minus the square root of 25 minus 36 over 6. And here we see that you have imaginary roots because you can't do the square root of negative 11. So this would have imaginary roots if you were to solve this. There's 5 plus the square root of negative 11 over 6, and 5 minus the square root of negative 11 over 6. And now the square root of negative 1 is equal to I, this imaginary number, just so that we can express it algebraically. So this would be 5 plus this I root 11 over 6, and 5 minus I root 11 over 6. So of course that's not a factor of 6, so that's probably your answer. Now definitely double check for the last one. So you do 3 times 12, which is 36. And this time you want to add or subtract to 20. And we can get a sum of 20 with this negative 2 and 18. Or positive 2 and positive 18 this time. So this would be 3x squared plus 18x plus plus 2x plus 12 all over 10x cubed plus 6x squared. Here you can factor out x squared, or actually 2x squared. So you have 5 times x plus 3, plus 3. Now for the numerator, you can factor this in those pairs, where you can take out 3x in the first two terms, and you could take out just a 2 in the second term. So that would be 3x times x plus 6 plus 2 parentheses x plus 6. And this is all over 2x squared times 5x plus 3. And now you can take out this x plus 6. So you have x plus 6, parentheses 3x plus 2, divided by 2x squared times 5x plus 3. Again, the denominator doesn't really matter, but because we see the x plus 6 in the numerator, you know that this is factorable by x plus 6. So here's the summary for number 12. Again, it got a little messy because you have to do a lot of factor by groupings. And this is for choice C. Choice C you can't solve, so that's why you have these imaginary roots. Next for number 13, if the set of four integers n to n, n plus 2n, and n plus 4n consists only of prime numbers, then the set can be called prime convergence. How many such sets exist? So here you have the sets n, 2 times n plus 2n, which is just 3n, and n plus 4n, which is 5n. So you want a set of these numbers in which they are all prime. So here, if you test any number for n that is prime, let's say n equals 2, our smallest prime number, then you'll get 2, 4, 6, and 10. If n is prime, then everything after that can't be prime because it'll be a multiple of 2. So the answer is going to be choice A. No other number can work. If you try a number where n is another prime number, let's say if n is equal to 3, then you get 3, 6, 9, and 15. Everything after that won't be prime because they have additional factors. Now, one thing that looks like it's going to work is to try n is equal to 1. That'll be 1, 2, 3, and 5. Now, in this case, 2, 3, and 5 are prime, but remember, 1 is not prime. 1 is neither prime nor composite, so that's don't fall for that here. The answer is, the answer is A, not choice B. So just be careful, our smallest prime number is 2. Next, for number 14, for the annual school fundraiser, Santiago has P pledges, each for C cents per lap that he jogs. If his school track has 4 laps per mile, and Santiago raises a total of $D, how many miles did he jog in terms of P, C, and D? So one thing you can do is just to plug in numbers here, but you can also solve this. Here he made $D, which in this case you want C cents, so you want to turn this into cents. And that would be 100 times D cents. And that's because $1 is equal to 100 cents. So you have to times 100. So he made this much money. Now he has P pledges for C cents per lap. And you know that 4 laps is equal to a mile. So 1 mile represents 4 laps, and he has C cents for each lap. So if 1 mile is 4 laps, you can figure out the number of cents he gets per lap is C cents. So you have to times it by C, which will be 4 times C cents. So each mile he jogs, he gets 4 C cents. Now that's for one pledge, so one person. He has P pledges, so P people are giving him 4 C cents per mile. So you have to multiply everything by P. So for P pledges, you'll get 4 times P times C cents. And this is for 1 mile. And that's for P pledges. So essentially, each mile he jogs, he gets this much money. And since we know that he got 100 times D cents, you actually have to multiply something on both sides, because this is rate, to figure out the number of miles, or M miles. So to get to M, you actually have to take 100D divided by 4PC. Because if you multiply 4 PC times 100D divided by 4PC, you'll get rid of the denominator, and you just get the numerator 100D cents. So if you multiply 100D times 4PC on both sides over 4PC, you figure out the number of miles that he jogged is 100D over 4PC. And here 104 cancel out to get 25. So it's 25D over PC. And that is choice A. So that's how you solve this using related rates or proportions. You can also just plug in numbers on easy numbers and then substitute in to solve. Next, for number 15, if x plus y times x minus y plus 4 minus y times 2 minus y is equal to 0, then what's the value of y when x is equal to 8? So you know x is equal to 8, so you just substitute in 8 for x. So you get 8 plus y times 8 minus y plus 4 minus y times 2 minus y, and that's equal to 0. So here you have to FOIL a whole bunch of times. So again, FOILing is the opposite of factoring. It's first, outer, inner, and then last. You can do this just 2 times distributive property. So just make sure to include the signs. 8 plus y, 8 minus y, this is actually your difference of 2 squares. This is 64 minus y squared. And here you have to include the signs. You got 4 times 2, which is 8. And then 4 times negative y, which is negative 4y. It's the first and the outer. The inner is negative y times 2, which is negative 2y. And the last is negative y times negative y, which is plus y squared. So from here, you can actually combine like terms. Negative y squared and positive y squared cancels out. You just have negative 4y minus 2y, which is negative 6y. And then 64 and 8 combine to form 72. So you know 72 minus 6y is equal to 0. To solve for y, you add 6y to both sides. And you get that 72 is equal to 6y. Divide both sides by 6, you get the y is equal to 12. And that's choice E. So here you have to FOIL and then combine like terms. A whole bunch of factors cancel out, and you just isolate y. And here's the summary for this page. All right, thank you everyone for joining me. Enjoy the rest of your day, and I will talk to you guys next time. All right, bye everyone.